Yeah, let's start. So could you share a screen, a uh, test that you took, and we can go through the questions that you have questions on? Yeah.
Mm,
Okay. Number one. So fx is defined as fx equals 2x minus 12. What is the value of x when fx equals 2? Okay. Yeah. Yeah, I think this will be a good question to get us both warmed up. Yeah. Mhm. So I'll share screen a whiteboard. Yeah, no worries. Can you see the whiteboard?
yes, sir.
Okay, yeah. So the question one, he asked for, so fx, some kind of function, is defined as 2x minus 12. And what we need to find is the value of x when fx equals 2, correct?
Uh, is it 7, sir?
Hmm?
Is it 7 fx, putting fx equals 7 and it will become 14 and 7?
Oh, yeah, that's true. Yeah, that's exactly how you do it. Yeah, so this is all same as 2x minus 12, which is equal to 2. So you send the 12 to the other side, 14, and x will equal 7. A very simple question. So did you get this one
That
incorrect?
was simple. I don't know how I got
You,
incorrect
you don't
here.
remember how you got this wrong? Maybe you misclicked a wrong answer choice. Yeah.
Maybe I had put the value of x in 2x minus 2. That's why I got wrong. I
Okay, okay.
maybe
Okay.
that was due to my carelessness.
Yeah. But you understand everything here, right? It's quite simple.
Yes, sir. Yes,
Okay,
sir.
yeah. Great. Oh, this is not it. Yeah. Could you share screen again? Mhm. Let's go to the next question. Okay, so what is the sum of two distinct real solutions for x squared minus 6x minus 16 equals 0? Okay, yeah. I'll put up the whiteboard again. Okay, so it is asking for x squared minus 6x minus 16 equals 0. So we have a function, this. It is asking for the sum of two distinct real solutions. Mhm. So you understand what this part means, Norwich?
Sir, I didn't understand what real solutions mean. That's why I think
Okay.
I put this on Desmos and
Mhm.
I calculated the sum from there. So
Okay, okay. Yeah, so what the sum of two distinct real solutions means is, so sum, adding up all values, but what do we have to add up? But we have two distinct real solutions. So last time, on last week's meeting, we talked about something called real roots, right? You
yes, sir.
remember? Yeah. It's been a kind of over a week, so it might be hard to remember, but going through it, I explained the word real means in math, so numbers that are, like integers, so one, negative one, 0, and also decimals, and also fractions. So any number
Yes,
that exists in real life. So yeah. So not things. So these are all real numbers. S- Things
really.
that are not real numbers are, for example, things like a decimal that never ends. So it keeps on going forever. This is not a real number. You can kind of think of it like that. Yeah.
Recording decimals.
Yeah. And things like a root with negative 4. This cannot exist, right?
Yes, sir.
So these are,
And also 5.
yeah, non-real. So we need to focus on real. So quite simple, any kind of numbers that exist. Oh, this is not it, sorry. So going to, yeah, the part called solutions, this part. What does solutions mean? Solutions is the same meaning as roots. So you can remember like that. So what it means is any value of the variable, in this case, it will be x, that makes this whole function true. So if you, for any value of x that makes this whole thing equal to 0. Do you understand?
Yes, sir.
Yeah. So how do we find values of x for this to equal to 0? So what we have to do is simplify this equation. So mhm. So a easy method to do this. So first off, you could have kind of a feeling of how to simplify. So you'll be simplifying equals 0. So, and the coefficient for x squared is 1, right?
Yes, sir.
So for both sides, they'll have x's that have each coefficient 1. So that once these two x's multiply, the x squared will still have a coefficient of 1.
Yes.
Yeah. And then this is kind of the tricky part, is you have to figure out these two parts, -16 and the -6x. Mhm. So, hmm.
That would be, I think, 8 minus 2. That gives minus 16.
So do you have an idea of what it might be?
Uh, 8 to the 16 and 8 minus 2 is 6. So
Could you repeat that again? Sorry.
um, in the middle there is 6. So 8 minus 2 is 6. And we have a coefficient 1 for x squared. So it would be 16. 8 to the 16 and 8 minus 2 is equal to 6.
Okay. So I think that is correct. Yeah. So if I give the answer, it will be this. Was this what you're talking about?
Yes, sir.
Yeah. So you can see, so equations that are kind of in the simpler part, like this one, x squared minus 6x minus 16, you can kind of know by a bit of feeling and intuition of what the answer
Yes.
might be. Yeah, so we can check that -8 times 2 is -16. And if we multiply x's to each, we get -8x plus 2x, which will equal -6x.
That is just-
Mm, Yeah. Oh, yeah. And so we simplify this. So we need to find the real solution. So values of x that will make sure this equals to 0. So what values would it be? Just looking at this.
So it would be x equals minus 2 and x equals 8. Uh,
Yes, that is correct.
right.
Mhm. Yeah. So, so if you get questions that's asking for some of distinct, two distinct real solutions, we found the two real solutions, -2 and 8, right? And
Yes,
so
sir.
we find the sum, so we add all these up, which are, so adding these two values, we get 8 minus 2 equals 6, which will be our final answer. Yeah.
It's
Is there any part that you're kind of confused about?
no, so just I didn't know the what real solutions means. So
Okay, okay, yeah. So now that you know, it's kind of easy to see how to do it, right?
yes, yes, sir. But I tried it through the Desmos. Can you?
That's once. Yes.
So I will
Okay.
test in the Desmos.
Okay, okay. So I'll show you how you could find the same answers and how to solve this using a Desmos graphing calculator. Yeah. So in Desmos, you get a sorry, kind of hard. Yeah. Okay. We got a straight line. You get a X and Y plane, right?
Yes, sir.
Like this. And then oh, yeah. So you get X and Y plane. Oh, I should have drawn this a bit better. Yeah. So and then you put in the equation, this part. But in order to graph it has to be a function of y and x, correct?
Yes, sir.
Yeah, so when you're looking at this equation, you can ignore the 0 for now and put in y instead to draw it. So we'll be drawing a y equals x squared minus 6x minus 16 graph. So it'll be a quadratic equation. Yeah. So the reason why we're changing the 0 to a y is because we have the equation about x on the left side and y on the right side. And with this relationship, you can kind of tell that we're finding values of x when y equals 0, right?
Yes, sir.
So if you put it this equation into the decimals calculator, you get a graph that kind of resembles this. Yeah. And then you'll be able to check that these 2 points that intercept the x-axis have values of -2 and 8.
Yes.
Yeah. So the reason, kind of the logic behind this is that our original equation was this, right?
Yes, sir.
Yeah. And then we drew the bottom one with a y. So the real solutions to this equation is when y is equal to 0. So that,
Yes, sir. So we are finding x intercepts.
yeah, that's exactly it. So when y equals 0, so when we find the x-intercepts, that will be the real solutions.
Oh, sir. Thanks.
Did you understand?
Yes, sir.
Yeah. So if you're having a hard time simplifying a equation through algebra like this, then you can instead put it in the decimals calculator. And then if you know that you need to find the x-intercepts, then you can quickly find these.
Oh,
Is everything good?
yes, sir.
Okay. Yeah. So shall we move on to a next question? Yeah.
Yes, sir.
Let's take a look. The graph of gx. And the graph of hx. Okay. Naraj, could you scroll down a bit to show me the answer choices that the question gives? Okay, okay. Right, yeah, thank you. Right, so we have a graphing problem. So I'll draw the x and y axes. Right, so the problem gives us a certain graph that is labeled as gx, which is equal to the absolute value of 2x. And that graph is shown as something like this. So this will be gx. Yeah. And then there is a second graph that is just gx, but it is moved to the right. So in the x direction by a length of 2. But this will be 2. And this will be a new graph called hx.
Yes.
Yeah. So we know gx, but how do we find hx? That's the problem, right?
Yes, sir.
So if we ignore hx for now and take a look at gx, we can see that when x is equal to 0, it's 0, right? Because there's no
Yes, sir.
constants, so you'll stay at 0. And then, yeah, and because it's an absolute value, uh the y's are always positive. So the important thing about, this question is asking the concept of uh, moving a certain graph in the x and y position, x and y axes.
Yes.
So let's say we have a bit simpler equation to explain this. Let's just say there is a graph called y equals x. Very simple, right?
Yes, sir.
Mhm. And let's say we want to move this y equals x graph to the right by 2. Then how will we do it? So if we move it to
Uh,
the right, the intercept will be at 2, and it will be a new graph like this.
yes, sir.
And how we write that new equation, this you could kind of memorize and also understand is it will always be y equals something, right? Because it's a graph. And then we have an x, but then instead of that x, so we put in the x, and then we put a minus, and then the value of how much we moved that graph. Yeah. In which case this will be 2. Hmm.
Yes, sir.
Yeah. So we moved the graph in the positive 2 by positive 2, right? So that's why we have
Yes, sir.
positive 2 here, and we have a minus in front. The reason for this minus is this will technically equal x minus 2. So this will be y equals x minus 2. And if we plug in, we know that the x-intercept is 2. So when we put 2 in x, we will equal 0.
Yes,
So we have proven that this moved graph is equal to x minus 2, right?
yes, sir.
Mhm. Yeah. So, hmm. So the thing to memorize, the form is if we move a, let's say we have a different equation this time for 2x, and we moved it to the right by plus 2 again. Then this will be 2. And instead
Uh,
of the x, we're replacing it with x minus how much we moved it. So we moved it to the right by plus 2. So it'll just be 2 here.
yes, sir.
This will be the case for moving to the x by plus 2 for 2x. Do you kind of understand the form that we're trying to do?
Yes, sir.
Yeah. So then if we go back to the original question here, we know that gx is equal to absolute value of 2x. And we move this to the right by plus 2. Then the new equation, hx, you kind of have an idea of what it might be, Norwich?
Two and get two simple bracket and x plus x minus 2.
Yes, that would be correct. So this will be the form of the new shifted graph.
Yes, sir.
Yeah. So, mhm. So this is the case for whenever we call it parallel moving or parallel shifting.
Yes, sir.
So we moved it to when we're moving it to the x within the x direction, we replace the original x with a new form of x that has a negative and the amount we moved it. Mhm. So if we moved it to the left by 2, so negative 2, then it would have been x plus 2, right?
Yes, sir.
Yeah. And then so this was the case for when we're moving in the x direction. Uh, because this parallel shifting came out, I want you to also know about when we have to move it in the y direction,
Yes,
right?
sir.
So what would we do if the question had asked us to move it in the y direction? I'll briefly explain.
I think we have to add if we have to move 2 units from the y-axis, we have to add in the let's say if we are adding to if I think we have to add a minus 2 here.
That's exactly it, Noraj. You got the hang of it, yeah. Uh-huh. So when we're moving in the y, so technically this hx, you can see it as just y, right?
Yes, sir.
So y equals, let's say we had the shifted in the x, then because for x, we replace the x with the minus of how much we moved it. We can do the same for the y part. So if we moved it, like you said, to the plus 2y, there'll be y minus how much we moved it, 2.
Yes,
Mm.
sir.
And then we move this 2 to the right side to have y equals absolute value 2, x minus 2, absolute value close, plus 2.
Yes, sir.
And this will be a graph for here. Mhm. So we moved it to the right by 2 and increased and moved it in the y direction by plus 2 also. Yeah.
Yes.
So do you kind of understand how we could move a graph?
Yes, sir. I
Mhm.
got it.
Yeah. So this is exactly just how you will want to do it. Yeah. So in the question, it asked us for, yeah, what is the correctly defined equation for hx? And we find that here, which is, and that will be answer choice C. Mhm.
Yes,
Do you understand, Arch?
yes, sir.
Yeah. Mhm. So just remember, when moving in x and y, we just do the change x or y by x and then minus thing and then how much we moved it.
Yes, sir. Sorry,
Mhm.
we are adding here we are adding by -2. It is because x minus 2 equals 0 and x becomes 2.
Yeah, that's exactly it. Yeah. So the reason why we're not just doing plus 2 is because if plus 2, then we know that at point 2 comma 0, that this point is 2 comma 0, right? So when
Yes,
x
sir.
is 2, y has to be 0. So if we plug it into this equation, we see that x, if we change it by 2, it'll be 2 minus 2, which is 0. So that
Yeah.
it all
Mm,
becomes 0 and the y value will be 0. And this will
yeah.
not be the
Yes.
case when if we did it as 2 times x plus 2, then it will not equal
Yeah.
0, right?
Yes. Got it.
Any other questions you have for this one?
No, sir. I got it.
You
I
got
got
it?
it
Okay,
all.
okay, okay. Yeah. Right. Yeah, let's move on to the next question then.